Hello, geometry students. Today we're going to talk about how to find the areas of segments of circles. So what is a segment? A segment is an area that's bound by an arc of a circle on one side and a chord of a circle on another. And a chord is a segment whose endpoints are on the circle. So that little yellow piece of area is called the segment of a circle. And notice, if you were to take the sector of the circle and subtract out the area of the corresponding triangle, you'd be left with the area of this segment. So thinking about area and subtracting out the area and being left with what you want is the key to this video. So pause, take a screenshot, or write this down. Notice you're going to have to remember how to find the area of a sector, which was our last video. You find the area of a sector because it's a fraction of the area of the whole circle. You're also going to need to remember how to find the area of the triangle. So if you've forgotten about either of those areas, you may want to go back and watch those corresponding videos. Now, just to remind you, there are two possible ways that you can find the area of a triangle. You could use the area of a triangle equals half the base times the height, remembering that the base and the height have to be perpendicular. Or you could use this formula. I'll be modeling problems and solutions with both. This is another formula that will get you the area of a triangle. You can take half the side length times the side length times the sine of the included angle. I'll say that again. 1/2 A times B times the sine of angle C. 1/2 side length times the sine of the included angle between the two sides you just used. All right, so let me model and then you can practice. In this, I'll model this example. If I want to find the area of this segment, I'm going to first find the area of sector ACB. Then I'm going to subtract out triangle ABC and I'll be left with this segment. So the area of a segment is the area of the sector minus the area of the triangle. So I have to find each of those areas separately. In order to find the area of the sector, I remember that the area of the sector is a fraction of the whole circle. What fraction? Central angle is the same measurement as the arc, so 60 over 360 is my fraction, times the area of the whole circle, pi r squared, where r is 18. And when you plug it in, you get the area of the sector over here in red. Now, let's find the area of the triangle ABC. In order to find that, we could do it a couple different ways. But because we have a 60-degree angle, we know that we know the radii are congruent, so we have an isosceles triangle. If we drop down that altitude of the isosceles triangle, it will bisect the angle, and we'll have a 30, 60, 90 triangle. And we know that this side will get bisected as well, and we can easily figure out all that we need to use our formula. The area of the triangle is 1/2 base times height. And then we can simply subtract those two things to get our final answer. So pause, practice on your own paper, and then press play for the solution. In order to find the area of this segment, we would take the area of the sector and subtract out the area of this triangle, and we'll be left with the segment we want. Notice, in this case, it's a right triangle, so the base and height are the legs, or the radii in this case. So that is another time when we could use that definition with that formula. So the area of the segment is the area of the sector minus the area of the triangle. To find the area of the sector, it would be a fraction, 90 over 360, times the area of the whole circle, pi r squared, where r is 4, minus the area of the right triangle, which is 1/2 base times height, or 1/2 4 times 4, because both radii are 4. And when you use your calculator, you can leave it in terms of pi, or you can get a decimal approximation. And remember to use square units for area. So pause, practice on your own paper, find the blue shaded area, and then press play for the solution. The area of the segment is the area of the sector minus the area of the triangle. And so to get the area of the sector, it would be a fraction of the whole circle, or 120 over 360 times pi r squared, where r is 6, minus the area of the triangle. In this case, I think the easiest formula to use would be half side, side, and sine of the included angle. Both the sides are radii, so they're both 6. So to use half a times b sine c, you'd say half 6 times the sine of 120. And then when you use your calculator to simplify, you will end up with your final area. Remember to use square units for area. Pause, practice on your own paper, and then press play. To find the area of the segment, area will be the area of the sector minus the area of the triangle. The area of the sector is a fraction of the area of the circle. What fraction? 90 over 360. And what's the area of the whole circle? Pi r squared. So fraction of the whole circle gives you the sector, minus the area of the triangle. Again, we have a right triangle, so we know the base and height are both radii, 8, 8. So we can use half base times height. And then use your calculator to simplify. And you get your area in feet squared. So pause, find the blue area, and then press play. So in order to solve this, you have to remember that this arc is the same measurement as the central angle, vertical angles are congruent, and this angle is the same measurement as this arc. Once you realize that, then you know that this sector minus this triangle will get you what you want. And so you have to find the area of the sector minus the area of that triangle. And we see that this is 60 degrees. 60 over 360 is our fraction of the circle, pi r squared, minus, and we can use half AB sine C, where A and B are both radii, and they're both 6, so half 6, 6 sine of 60. And then we subtract and simplify, and we get our answer in square units. So that is how you find the area of a circle segment. And so I will leave you with these cute puppies and wish you a great day.